Well, hi, good morning, and thank you so much for joining me in my shop here. It's March 27th today. And as you know, my channel is all about working on this old technology. But I'm going to show you something that I think you should be doing. I'm going to try to encourage you. If you're not, you should be doing this. And that's using AI in conjunction with everything you do all day long. I'm just going to show you an example here. I'm not doing this in any kind of special way or whatever. Let's just take a look at my computer here. I'm just going to do this for a couple minutes and then we'll get on with what's happening with this radio. The reason I want to show you this is because it's so easy and it's so effective. It's really flooring me. So this is in Microsoft's browser. Their AI is called Copilot. That's the name they use for it. So look what I wrote in here. This is what I asked it. Just like this. Tuned IF bypass capacitor. What can you tell me about that? Look, I didn't punctuate it properly or anything. I talked to it like I'm talking to a person. Here's the response I got. I'm not going to read this to you. You can look at it on your screen and you can just see how decent this is. I mean, this came back in just seconds, of course. The last thing it says is, in summary, bypass capacitors are essential for maintaining stable voltage levels, reducing noise, and ensuring proper circuit operation. Their behavior depends on their capacitance, frequency, and the specific circuit they are used in. It's fantastic. This is fantastic. And I've used it for all kinds of things. I've asked it all kinds of questions that you just think it wouldn't even understand the question. And back comes the answer you're looking for. So fantastic. Copilot is this little, in the Edge browser, it's this button up here in the top right corner. You click on that, up comes a little window, you ask your question, then stand back because this is the way the world is going, for sure, rapidly. So get on to it. If you're not doing this, try it out. I'm sure you will like it. Like, for instance, if I type this into my browser, like my regular browser search, I don't know what would come back. Not a beautifully formatted answer like that. Anyway, I just wanted to encourage people to start using this right away. I'm sure it's available in other browsers and through other vehicles to get access to it. But in the Edge browser, it's very easy. It's just click this button and fill out this little box down here. Okay, what about the radio? You gotta wonder if the day isn't coming where, actually if the day hasn't arrived already, where every question you've got, you can get a pretty decent answer out of a machine in a fraction of a second. Any question you have, you can get a pretty decent answer to it out of a machine in a few seconds. That's not the way the world has been. Don't you remember getting on your bicycle and riding up to the library and poking through the shelf to try to find a book and then leafing through the book to try to find an answer? That's impossible. What a world we're in. That's why when people say, we're worse off, my parents were better off, my folks were better off. No, they weren't. No. No. Open your eyes. Pull out that supercomputer you've got, which is fantastic. Pull it out. Make a phone call. Do something. Face up to the fact that we live in a world that would have made the Jetsons jealous. That's where we are. Where Captain Kirk would have pulled out his communicator, looked at what we got, and just thrown his away. Just a piece of junk compared to what is really existing and we really use. Unbelievable. Okay, so much excitement. Yeah, I just hate it when people feel negative about the world. That's a dumb way to go through life. Okay, now, what about this radio? So I think this radio is working essentially the way it should, except for one thing. This is my theory on this. Okay, we're going to find out today if my theory is correct. It's the one capacitor that I have left in the circuit. Oh. Because I wasn't sure what to do with it, and I thought I better just leave it right to the end. Let me just tip this back like this for now. Leave it right to the very end if I could, where if it is having an influence, the influence might become obvious. The radio's still weak. And in analyzing its function, this big capacitor here, it's clear to me that if it has deteriorated a little bit, it may become a real bad actor fast. Whereas other capacitors, a little bit of deterioration in the capacitor causes a little bit of deterioration in the performance of the radio. Often not even detectable deterioration. Remember, we have the overcomer control that can overcome almost every problem in a radio. It can even overcome problems in your car. The overcomer control is the volume control. You just turn it up. So your radio's a little weak, you just turn it up a little bit. You don't even know you're doing it. In your car's making some kind of horrible noise. You can't stand hearing it. It sounds like it's going to fall apart. It's a rattle trap. Just turn the radio up. Turn it up. And the rattle will be gone. So I'm going to approach this as experimentally as I can in order to understand more about this capacitor. And I also want to always be in a position where I can just reinsert it in the radio, because this capacitor is very, very special. This capacitor has a coil in it somehow, and it's in series. It's a series capacitor and a coil. How it is in here, I don't know. I can't even imagine how they've done it. Maybe they've, well, I can't imagine. Maybe they wrap the wire around the outside of the formed capacitor, and then they make a connection so the coil becomes in series with the actual capacitor element that's inside underneath the coil. Probably if we scrape this away enough, and there's probably a layer of paper or something protecting it, we'd probably find these wires going around it. I don't really know. I don't know how they've made it. And unfortunately, Bing didn't tell me anything about this particular capacitor. The Bing answer was a general answer about using capacitors in a bypass position in electronics. It wasn't a very specific question. I could get more specific with it, maybe. This is probably a fairly obscure thing, and maybe the AI knows nothing about this. It's surprising what it knows about, I gotta tell you. It is really surprising. So a couple of approaches here. One is find out, like there's a couple of big approaches. One is, cut it out, put another capacitor, and see what happens. No, I'm not doing that. Another one is to test this in the circuit somehow. How could that be done? And another one, the one I'm probably going to do, is to cut one leg off, one wire, one lead. The capacitor is no longer involved in the circuit of the radio. It's free at that point, even with the other lead still connected. And then I can perform tests directly on the capacitor, including, well, I can do quite a number of things. Yeah, but I think the first thing I'm going to do is drink some coffee here and get ready for this. I want this to be as interesting as possible. That's for me. I'm looking to make it interesting for me. And you too. Maybe one of the interesting places to look for trouble here is in the trouble chart and see what they blame 303, capacitor 303, that's the one we're dealing with here, whether they blame it for anything. So if we look through the list here, these are all 100s. These are 200s. These are 300s here. No 303. Here. So the idea is if it shows up in this list, then they're blaming that capacitor for bad performance. Maybe that would just help us understand things a little better. No, it does not show up in the list. At any point, there is nothing that can happen to this radio that they would blame 303 for. That's a little suspicious, isn't it? There's 303 right there. You can see it very clearly, how it's connected. And there it is going right down to the chassis. And this guy is supposed to improve. Is it written up in here? Did they write it up in here? No, they did not. The only place they've written it up, or mentioned it, just mentioned it, is way down here, this paragraph in circuit description. Condenser 303 is a special condenser inductively wound to form a series tuned circuit resonant at the intermediate frequency. Now, this must be pretty challenging, making a capacitor that is that finely tuned. This condenser offers less impedance at this frequency than a conventional condenser and thus permits higher IF gain with no tendency towards instability. Instability, I think they're hinting at oscillation. Well, this isn't really telling us too much, is it? Nothing more than we already knew. Okay, let's go back to the radio here. I didn't mention my great disappointment this morning when I went upstairs a couple of minutes ago to get a cup of coffee, and I hadn't put any water in the coffee maker, and I'd made nothing but a pot of hot air. But soon it'll be ready. So let's try something dumb here. I'll take this rather cool test instrument. I'm going to hook it across that capacitor with it right in the circuit. It's just probably a nonsense thing to do. Let's see what it says. Okay, so it says it's a capacitor with a 12% loss. And the capacitor value is 1.5 microfarads. 1.5. This is supposed to be a 0.2. So I think what's going on is the instrument here can't read certainly a capacitor of this sort because it has this coil thing happening in it. But any capacitor that's leaky will start giving you false readings on you. You get higher and higher readings of capacitance. And that's probably true of every capacitor tester. Okay, so that didn't do any good at all. Of course, I can cut the wire. I don't want to cut it just yet. What kind of operating test could we do on it? We have the radio operating. Apply some kind of a signal that's going to reveal the resonant point of this capacitor. And is it really resonating at 455 kilohertz? That's where it's supposed to resonate. Or is it off? Which I think it is. Yeah, you know, there must be a way of doing this. I got to think about this one a little bit. Okay, here's my first attempt at finding something out. I have a sweep generator operating here. This is producing a radio signal. It's sweeping from a lower frequency to a higher frequency and doing it at a nice steady rate. It's starting at around, I'm not sure, let's take it, I can't remember. It's starting at 400, no, I'm starting way low at 144 kilohertz, and it's going all the way up to about 700 kilohertz. So starting way low, going all the way up. In the middle of that range is, roughly in the middle, is 455 kilohertz. This is supposed to be tuned to 455 kilohertz. It's a series resonant circuit. A series resonant circuit impedance drops at resonance. Parallel goes up, but in series it drops because the two reactive components cancel, and all you're left with is the resistance of the circuit. So we should be looking for a high impedance and then a drop and then go back up again like that. And this frequency will mark the tuning frequency of the capacitor. So I have the sweep generator sweeping through the appropriate frequencies attached right across the capacitor. And then I have my oscilloscope over here also right across the capacitor. Is this really the best way to do this? Maybe not. I don't know. Be hooking up the equipment to the capacitor may affect its function. I'm not sure of that. I actually kind of doubt that a little bit, but it's a question mark in my mind as to whether this can be even effective. So I'm looking for some kind of dip to mark where the resonance occurs. Outside of the resonance, this presents a fairly high impedance to the signal. So the signal from the sweep generator should remain high. When it reaches the resonant point, and this thing basically drops to zero resistance, zero impedance anyway, that'll cause the output of the signal generator to collapse. And it'll come back up on the other side when it crosses that critical frequency. That's what I think. Let's look and see. There's nothing on here now. So I have a camera up there. You can get a close look at the oscilloscope display here. Now Now the oscilloscope is not sweeping on its own. I have it set to sweep based on a sweep signal coming from the sweep generator. So that's why it's always low frequency here, high frequency there. Somewhere in the middle is the 455. And somewhere in there hopefully we'll see a resonance, but I don't see a thing yet. So I haven't got this really very sensitive. Right now it's set to half a volt per division. Let's make it more sensitive here. Okay, something happening. Well, okay, let me make it a little brighter. That's interesting. That is very, very interesting. Now, before we jump to any kind of conclusions here, you'd have to guess this is the resonant point here. Now, what exact frequency that is, I don't know right now. I'm going to have to bring another signal generator here as a marker generator and mark this, and then we'll find out. Where did I start? Let me just check again. Okay, I'm starting at 150 and ending at, wasn't it 700? 150 and 700. So 150 and 700. Wow, I don't know what's in between 150 and 700. 150, 700, 550, 550, 275, 275, 153. I don't know. That's why I got to use a marker. I think this is way low, offhand. And what if the capacitor is leaky? It probably is leaky. That's not going to help the situation any. I'm not sure what to make of that. Is this really a believable test? Well, I don't know. Let's keep going. Find out. We need some more evidence of what it's doing. I'm going to think about how to do, like, the radio's not operating, right? I just did this passively. I wonder if I can set something up and we can see the effect of the capacitor right in the radio. I wouldn't think that's too difficult. Now, this side of the capacitor is grounded to the chassis, not to the B minus. There's a wire going off here. Something else is grounded to the chassis. I think that has to do with the antenna. So if this is not B minus, can I hook my? What I'm pondering is, can I hook this up? This is being supplied by an isolation transformer, so I can put a ground on anywhere I want. One ground anywhere. Two grounds, no. One ground anywhere. I think I can probably do it. I can probably put a ground here. It would be no different than putting a ground like that. I wouldn't be too afraid to do that. Why would I be afraid to do this? It's the same thing. So put a ground there. Then my oscilloscope impedance can be set so it's 10. That's this way. Well, I can run the radio and I can do this. See if it makes any difference on the radio. And then I can take this sweep signal and jam it in the radio so it comes through the radio somehow and it reaches this capacitor. That would be my plan. And now I got another ground connection. And I can't put this ground connection anywhere different than this one. So I'd have to ground it on the chassis. Oh, that's not going to work out well. That wouldn't work out well. I have to ground it. But I can't put it on the B minus and the chassis at the same time. That's definitely going to completely disrupt the operation of this. I'll basically have to put a short circuit across it. Good thing the coffee's ready. I'm going to go drink some of it and think about my next move here. So I've been thinking hard about this, how to make this connection. This is my signal generator here, and of course it's got the power system ground on it, and so does my oscilloscope, and I have this problem. I want the oscilloscope to be looking at the capacitor, so the connection should go to the chassis for that. I want this to feed a signal into the grid of a particular tube, and this should go to the B minus for that. And I can't do that. I can't put these two things are the same thing electrically. It would just be like putting a wire across from here to the grid. If I try, how about I hook up a loop to this and then feed the signal into the radio through its own antenna. I don't think that's a good idea offhand. The situation is so complicated to think about. I'm going to stop thinking. I'm just going to hook up that loop, a little loop. Where'd my little loop of wire go? I have lost it. Well, it's not the only loop I've got. I've also got this one. So I'm going to try a looping in. I'm going to try to impress this signal on the radio antenna. And we're just going to see what happens across this capacitor. I don't know really what else to try right now. Well, I'm thinking up better ideas. Let's do this bad one. I think that's the way to look at it. So volume down. Still have this meter connected. It's inconsequential. Away we go. Now, hard to see the oscilloscope here. Okay, let's just let it warm up in case something exciting happens. I don't have the oscilloscope connected. Jim. What's all the crackling? What's all that? What was all that? So that buzzing sound is my sweep generator. All that swooshing, where'd it go? Went away. Wow. So there was a lot of crackling, swooshing sort of sounds. To me, it sounded like a component failure, component breakdown. Who knows? I don't know. Okay, we're already started the experiment here. Okay, I'm going to stop for a minute and I'm going to rearrange the camera just very quickly here. Okay, we'll carry on here. Yeah, I stopped the sweep. You notice on the scope the sweep stops also because the sweep signal coming from the signal generator over here is turned off. I'm going to turn it back on. Okay, and we don't have this connected. Go now. Connect this. A lot of signal there. What is this telling us? I don't know. The sweep speed seems slow. I think because I encountered this before, my sweep generator appears to be running 1/10 the speed it's intended to go. This is 1 per second. Yeah, it looks like about 1 per second. This would be 10 per second, and this would be, well, maybe it's okay. We're certainly not seeing any kind of shape in here at all. Nothing. It's probably a bogus test. It's probably really what I'm looking at. Let's put the sweep on normal. What this is going to show us is probably nothing much. Yeah, I don't know what we're going to make of that. It's not going to... You're not going to learn much out of that. Okay, so this little experiment didn't provide anything. And the question we're asking is, what's the resonant point of this capacitor? Is it really 455 still? Is this really the problem to the radio? Ultimately, the question will be, if I can prove this to be bad, the question will be, can you just put a regular capacitor in there? There she goes again. Is it the volume control? No. Yikes. I don't know what that was. I'm tapping my bench and it started. A lot of strange sound coming out of it there. Not from this. It's gone away. And ready next time that sound comes up. It doesn't sound like the kind of thing you can tap. Doesn't seem to be particularly sensitive to the volume control either. Yeah, nothing here. Something here. This one pin here. So it could be nothing more than the tube is not in the socket absolutely correctly. In fact, you know, I got the radio laying on that tube. Yeah. I think it's probably just a tube socket, the pin shifting a bit in the tube socket. Maybe from heating and cooling or other effects. Okay, not to worry too much about that. Now, next step along the way might be to cut one leg off the capacitor and test it in other fashions outside of the radio. I don't want to do that just yet. So let's think about this. The radio's IF is tuned to 455, so what comes out of the speaker has to have been 455 kilohertz, been converted to 455 kilohertz to come out. That same frequency, 455 kilohertz, is the frequency that this resonates at. This basically disappears and turns into a piece of wire at that frequency. But what if it's not working at that frequency? It's drifted off. So what it would be doing is it would be making the radio more sensitive to the wrong frequency. Now, much of the radio is tuned to 455, so you go down the way, other frequencies are not going to make it. Only 455. So if this thing's resonant at, let's say, 400, I can't work. You're not going to hear anything out of the speaker that has something to do with 400. In other words, if I make this thing resonant at 400 somehow, I'm not going to find it this way, I think. The radio itself is not going to play a sound and convince me, oh, this is not right. Let's look at it. Maybe I can imagine this better with a schematic in front of me here. So we're talking about this capacitor here. And it's basically on this line, and a lot on the B minus. It's basically connecting B minus. Now wait a minute, now how can this have a big impact? Well, it's connecting B minus to the chassis, and at 455 kilohertz the connection is very solid. How does that help anything? How does that actually help anything? I had in my imagination, I had got this thing located up here somewhere. I was thinking about it in a different way, incorrect way. So I think the problem here is if you just use a capacitor, well, why is it even a problem? I was going to say, if you just use a capacitor, then you have some amount of reactance in the capacitor all the time, and you won't achieve this great result. Well, you can knock off the capacitance at one frequency by making a resonant circuit with a coil. You can get the capacitor out of there, a coil disappears too at the resonant frequency. And that means, well, what else is hooked to? So this is hooked up to the chassis, this is hooked up to the chassis. Basically the antenna system. Kind of. I don't know. I'm not thinking anything good up here at all. Yeah, I gotta stop. Now I think all I'm left with here is to cut one leg off the capacitor and continue testing it. I mean, ultimately I could put another capacitor in there and see if the radio works better. That's a way to go. I could even leave this one connected and just hanging out. I could leave one side connected. Okay, now where exactly is it connected? So it's connected to this bottom terminal with the yellow wire on it. Everybody remember that. In fact, I'm going to cut it with, leave a little bit of wire there. I can't make a mistake. The radio's switched off, but that's better. Okay. I've cut it. I've done it. Oh my gosh, it's cut. Now, what does it say on it? Special. It says right on it, special. Okay, it's a special, all right. I think it will repeat the very first thing I tried, which is to put the sweep across it. I wonder if I should have a resistor in series here. I think I need to put a resistor in series with this. Otherwise, I won't be able to see the variation. It won't be obvious. What size resistor? Oh, that's a good question. Not very big. Maybe a 1000. How about a 1000? 1,000 in there. What about 1,000? You know what I'll do? I've got this guy here. Many resistances to choose from. So this is a decade box. That's a capacitor and a resistor. There's the resistor leads, so I can set the value of the resistor. And in here is just a whole pile of resistors. So what we want to do is we want to put this here. And then the other end, if we're looking at the signal generator, we would put the one end here, the other end across the resistor. So that sets up a voltage divider. This is going to go here. Between the capacitor and the resistor. And the idea is the voltage division between these two things is going to be frequency dependent. So as I put a bunch of frequencies through it, they will react differently to these two parts in series. And we should see it on the oscilloscope. That's the idea. Well, yeah, you can already see the oscilloscope. Let's get this going. Now, I don't see much there yet. Now we've got this set to very low resistance here. Oh, it went down. Okay, a little surprising. I can see just a little bit happening here. Make this more sensitive. Increase the signal here. Now, this is reminiscent of the last place we saw a dip, but I don't know what frequency that is. This test, I feel, is probably more reliable. Let me change this resistor again. Okay, it's not doing what I thought it would do. That's no resistor. No, that's a huge resistor. That's a small one. That's 15 ohms. What if we get rid of it? Maybe my thinking was completely defective here. Let's get rid of it. So to get rid of it, I would do this, and I would do this. Yeah, you know, we don't need this resistor. Defective thinking. I'll have to work on that later. Okay, there we are. So the question is, what frequency is happening right here? You can also see it. I mean, the range of frequencies coming through here was like 150 to 700, and the difference here isn't all that great. I mean, this doesn't drop to zero. This doesn't drop to a... If this dropped right down to zero, then I'd say, wow, look at that. And then I would be more hesitant about just throwing a capacitor in there. Can I just put a really big capacitor in there and get this down? Of course, all this would come down then. Well, it wouldn't matter. Would it? Or was it going to introduce some kind of instability in the radio? It's going to oscillate or something. Well, we can find this out down the road. So I got to introduce another signal generator here and feed the signal in where we can see it. How am I going to do that exactly? Oh, found the missing coil. There it is. Not that we need it. Okay. So I just feed this in right in parallel. Now this is very low impedance. I'm pretty sure this is low impedance too, so it probably doesn't matter. Probably doesn't matter. I'm just going to feed this right in. Yeah. Okay, so I'm going to clip this on here. Now let's watch the screen. What's it do? It doesn't react at all. I thought it would get smaller or something. Surprise to me again. The frequency I'm sending is a very high frequency right now relative to... Get on here. There. Okay, so we have a sweep signal going through it. We have an oscilloscope watching what's happening, and then we have a fixed frequency going into it also from the other signal generator there. You can see the frequency we're putting in. And we don't see anything here. Now what we're going to see here when I get this close is this is just going to become disturbed. That's what I imagine. When I get this down around, let's go down here. Ooh, right on 455. In full blast. Okay, now we move it around. Can you see? Right here is a disturbance. Can you see that? I'm going to go full screen on the on this for you. It's very hard to see. Very, very hard to see. Right, my finger is pointing at. No, you can't see it on there. There's no way I'm going to be able to show this on camera. Actually, if you look really close, you can see the top line is bopping. Yeah, you can actually see it. The bottom line too. A little shake right there. That's marking 484 kilohertz. Now I'm going to move this down, 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 down until it's right in the dip. Okay, so it's in the dip. Can you see it? It's right past the center radical, right there. So I have it in the dip. What is the frequency, Kenneth? 391. So that's supposed to be 455. If this test is done correctly, if this is working the way I think it is, then we've shown that this capacitor is resonating way off of 455, down at 391, which is useless to the radio. We can see that the resonant for 455 was up around here somewhere, and you've got this much reactance, whatever that means. I mean, this is not a calibrated test by any means. Okay, so the result is this device they put in the radio to make it work better appears to be no longer helping it. In fact, it may be hindering it. So what size capacitor should I put in there? It's a 0.2 to begin with. Why did they pick a 0.2? Because why would they pick a 0.2? At the resonant point, the capacitive value doesn't matter anymore. Is that a true statement? So why didn't they just use a little tiny capacitor? Because they had trouble making a coil that would resonate against a tiny capacitor. So in order to make this thing work, they were forced to make it this size because of the needs of the coil. I don't know. Sounds good to me. I like that story. Well, next experiment is to put in another capacitor and see if the radio works better. And we just have to pick the size, which is kind of what I was trying to analyze there. Probably start with... Well, typically this is a fairly big capacitor in a position like this. I'll see what I got. Maybe that's what I'll decide. What have I got? Okay, got an idea. I have a substitution box right here. And the substitution size goes up to 0.2, which is a fairly large capacitor, similar in size to this. Why don't I put this box in, adjust the size, and see what happens? Try different sizes with the radio operating. So in order to do that, I gotta remove all this stuff. Everybody off. Okay, everybody's off. Just turn that down. Now I'm gonna want to have some kind of signal I'm listening to. That radio station would be best. So why don't we set it up that way? So we got a radio station going here. So we're going to need the booster and the outdoor antenna. You can use this coil here quite handily. Should give plenty of signal. Pick up some station. Stay on there. And we're going to want to connect this up. I'm going to start with a point 1. Did I bang the camera down or something? And now there's no concern about grounding or anything like that. So we're going to go here. This is just an isolated thing floating in electrical space. Let's see. We want to put this on the correct terminal. It was the one with the white wire. Yep. Okay, now this could present problems. There's a long wires coming out here. That in itself can be a problem. And all this unnecessary wire on my bench. So I'm going to straighten things up and we'll try this test. Okay, I think we're ready now. There's a good chance this radio is not going to work at all. We're not going to receive anything because this just isn't going to work out. But let's give it a go. I'm set to 0.1 here. This is okay. Still, these clip leads have a way of wandering around. After you clip them, they have a settle down, and they can settle down and cause a short. Okay, I'm good. We're all good here. This is the antenna, which is switched on. Here we go. So the idea is tune in a station and then fool with this capacitor size. See if the whole thing works better than it used to. Oh, I forgot to take the inset off the screen here. While it's warming up, I'm going to do that. I'm going to take the inset off. Okay, well there's our familiar, that's full volume too. Familiar interference sound. Generally volume very low, I think. I should push this back on and off like a switch. Let's tune around. Okay, most stations are down this way. It's getting a lot louder, right? I don't think it's correct at all. I don't think this is working well at all. I don't think we're getting anywhere ahead. What happened there? What happened? Is it? I've knocked this tube out over here, maybe. Okay, not really quite sure what happened there. I don't think it has anything to do with this stuff. Well, there was a lot of volume there. I had to turn this right down. You just have to ignore the popping sound, the interference. Where'd it go? There's a station right there. Okay, we'll try this now. Smaller. 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 Really small. Almost not there. Ooh. .001. So there's a swooshy sound. You hear that swooshy sound? Let's see what happens to that. Did away with it. Hey! I got bad parts in here. I went silent there. Wow, trying to explain all this. Volume up. How much volume is there? First of all, down. Look, I barely got it turned up. Loads of volume.
Well, the public is going to weigh in.
Loads and loads of volume. This radio is better without that part in it. How can that be? Are you serious? I actually have that part removed, and the radio works better. Okay, what if we disconnect this? This guy. That's not a good idea. There's a low growl in there. What's going on here? It seems to... How come we had it and now we don't? Where'd you go, man? What happened? I don't like that. Don't. Ooh. What was that? You know, I think maybe I'm knocking it too. Well, we got something out of this. A small .001 capacitor in that position, according to this, appears to be ideal, getting a lot of volume. Suppose I put a .01 in there sort of temporarily. As for what else has happened to it, I don't know. We can't really tip the radio up with all this stuff hanging out of here. Fantastic. I mean, we heard it work. We know it's in there. It's got it in it. Can I get it out of it? Okay, so I'm going to, yeah, we'll try that experiment. Okay, I've soldered in a small capacitor, this one here. Good. This is the old one I cut out. Just reading it here. Philco trademark. Some Philco number 30 dash whatever. There's a number, a serial number. 0.2 400 volt. 400 volt in this position. Special. There's the number again. 30 46 44. 2 in a circle. It says 303 right on it. Isn't that's the part number? That's how specific, you know, it looks like. This is so specific to this radio, and I'm sure it is, that, you know, this is all there is. If you want another one of these, you got to get another one of those. That's what I think. But I haven't done that. Instead, I stuck this little capacitor in here. We're going to give it a go. Let me just make sure I can tip this up into a more normal position. Amazingly, I have not broke the antenna wires yet. I'm pretty surprised on that. Okay, we still have the loop helping out here, or the coil rather. My external antenna. Volume is down. Make sure these tubes are in. Yeah, see, that tube was partly out. And the pins are very short on these Loctite tubes. Maybe that was all it was. Let her rip. Volume down. Yes, volume up a little bit. And we're running it with 107 volts, 108. 109. Wow. Volume?
7.9 billion. It's actually moved a little
Wow.
higher today to 8.9 billion. And this, of course, adds billions to the former U.S. president's fortune. He's got a 60% stake. However, he can't sell shares for about 6 months, and that gives the company time to test that valuation, despite the far from robust results. This stock has also been categorized as a meme stock because of the social media frenzy around it. Now, the original meme stock, GameStop, firmly in the red today, shares down almost 50%.
Okay, there we go.
Game retailer did report earnings.
You know, the swooshy sound, or the tone whose pitch is changing? Probably related to the capacitor I put in there.
I don't know. This certainly has a light day in 4. So the Dow is up 5, the S&P higher by 4.
Yeah. Now, seem to change up on the high part. So much interference in here.
Moving higher as well, up by about 26%. Just ahead of the release of U.S. supply data, and we are expecting to see a build in crude supplies last week.
Okay, I'm not going to move this antenna away. We'll see what happens. It sounds weird, doesn't it? Sounds a little like single sideband. So that's literally from having too small a capacitor in that position. This pitch, I believe. And what's going on in the higher area here? I don't know. Is anything going on? Ooh. Wow, some very, very low oscillation there. It's almost bothering my ears. Wow. Yeah, so we have some weird artifacts in the radio now because it's no longer the way it was designed with this guy out. It's doing some things that engineers would take steps to resolve by installing one of these. See, it could be that the radio's been designed with this in mind. So with this out of the circuit, this is not your typical radio, and so typical solution's not going to work well. Maybe, I don't know. Bigger capacitor there, I think, would stop this. Because we can't have that. Interesting that a stronger antenna. So I've got it right on the mark, but now there's a very low frequency. This speaker's just rattling like crazy. So I've brought the tone down to the point where you can't really hear it, but it's still there.
Licensed insolvency trustee. People to planet. Needs to be seen on the big screen. Empire. See it in IMAX.
sized that capacitor with this loop sitting on here. So I sized it for this, but not for that. I think that's probably the nature of the mistake. Okay, we can do a little more experimenting here and see if that's the case. Okay, let's try this again. This time without the boosting antenna. I'm going to move it over here, out of the way. So I'm just going to put this in parallel with the capacitor. This is the one I just installed. I can leave this capacitor in while I'm doing this. It's a small capacitor, so I'm paralleling in another capacitor. It would just add to the capacitance value. Okay, hopefully we can pick up a station. Yeah, I have to use this antenna just to get the radio tuned. Okay, ready. Here we go. Here we go. Away we go. So just having this connected, I've already doubled the size of the capacitance in there. So you can hear a station. Sounds pretty bad, and a whine with it. The idea is to get rid of that whine. Oh, we got rid of it all right. Got rid of everything. That's a 0.2. That's a 0.1. That switch here. It tuned us. That's instability. Well, how do you get rid of that tone there? I don't think I can do this. Just getting my hand close to it is changing it. Let's try this. This is dumb. Like, these wires hanging out here are not helping the situation at all, I'm sure. In fact, let's remove that for this experiment here. Let's remove it. Didn't make a lot of difference. Parallel this one back in. Oh yeah, I got a clip lead for this. Yeah. Did I not solder a wire down here? Oh, I don't think I got this wire soldered here. But it must be making contact. Yeah, must have been making enough contact, but I didn't actually solder the capacitor properly. Oh boy. Oh boy. I don't know what to think here. So I'm going to stop for a bit. Let my brain catch up. Well, I had to revert to studying up on this. So I've gone through my books here, some of my books, looking for any information I can find about this. Look at this one. Old-time radios. How to repair old-time radios. And then these three I have here. This is the mother lode of information. It's the same book, different releases of the book, including the final one here. Done by, where's his name? Abraham Marcus. There's another guy. Marcus and Levy. And this one is, I think, Marcus and Levy again. Look through all these books. Nothing said about, I couldn't find anything, believe it or not, about the capacitor connection to the chassis like this. And this type of capacitor, couldn't find anything. So and not surprising. I think this is an obscure thing that was done here. I don't know how many radios would have something like that in it. I've never come across exactly this situation. So looks like just putting a capacitor in there is not going to do the trick, because every time we tune in the station you hear a heterodyne with it, and it's very bad. Heterodyne is an oscillation produced by the mixing of two signals. That's what's going on. Something of that sort is happening. How this capacitor plays a role in that, I'm not exactly sure. So for now, I don't know what to do here to make this radio work better. I mean, one possibility is to try to recreate this, get a capacitor and get a coil, but I haven't found any information about, how many millihenries the coil is in here. I don't know. I will continue my research, but I don't think it's going to be fruitful. Okay, Mr. AI Copilot, can you help me with this? So I asked it this question. What can you tell me about a Philco special capacitor number 3464? And here's what Copilot said. The Philco special capacitor with part number 39 is a component that was commonly used in vintage Philco radios. Unfortunately, specific details about this particular capacitor are not readily available in my current knowledge base. Well, it's not available in my knowledge base either. However, I can offer some general information about Philco capacitors and their replacements. And then he goes on and just, sort of dumps out whatever he can say. But look at this last part. Additional considerations. This is the thing about using AI. The blue capacitor you mentioned, but I didn't mention the blue capacitor, should indeed be replaced if it's part of the original circuit. Well, I didn't mention anything about a blue capacitor. The component labeled blah blah appears to be a transformer. What? Well, what are you talking about? Pay attention to the black box located what? It contains what? So, yeah, AI goes off track quite regularly in doing these things. So anyway, this didn't help. Remember that vintage radio restoration involves both technical knowledge and attention to detail. If you're unsure, consider seeking advice from an experienced hobbyist or consulting specialized forums dedicated to vintage radio enthusiasts. Well, that's probably the best piece of advice in there, is ask the guys on, this must have been discussed on vintage radio discussion. Okay. Hey, I'm going to look for that now. After a lot of searching, I found this on the Philco forum. He says, howdy, I'm restoring a Philco something or other. One of the capacitors is a 0.2 microfarad with a wire wound 7 times on one side that goes to chassis ground. Well, that's exactly what we've got here. What I'd like to know is, what the heck is this? Lots of laughs. Can I replace it with an orange drop 0.2? Need help? Well, here comes the answer. Someone mentioned this in a recent thread, that this subject comes up quite often, and they were right. The theory of operation of these special capacitors may be found at Chuck's site. I haven't gone there yet. Now, to answer your question. Generally, yes, you may replace with a modern 0.2 microfarad cap and not worry about the coil. But if you have any squealing afterwards, go back in, wind 7 turns of 20 or 22 gauge wire around the new capacitor in the same manner, same direction of winding, same number of turns. So he's talking about the original capacitor as the original winding, and reconnect the radio. So here he's saying rebuild that capacitor. It's only 7 turns. Okay, so that's a little thing I didn't know. How many turns of wire and what size wire to use? Let's go here. The Philco repair bench. What happened there? Sometimes I have a lot of trouble with my mouse in this shop. There we go. I think there's interference. Okay. What? Where are we here? This page has moved, has it? Wait a minute. How can I click here? Quickly click here. Quickly to go there. What? Oh, this is not working out, is it? It doesn't look good. Well, that's really disappointing. What did he say? Philco repair bench tips. Service tip number. Just try it again. Not that I expect anything different. No. Okay, well, I'm going to try to find this Philco reference because I want to read up on this stuff. So that's what I'm going to work on here. Okay, so I did check the Philco repair bench website. I've been there before. It's a very good source of information. It's really wonderful. We're working on a Philco radio. It's worth looking at that website. But unfortunately, couldn't find a thing out about this. Nothing. So all I have is that one reference on the forum that said there's probably 7 turns of wire wrapped around here. And I think he even suggested taking it apart. You can see something is running right under here. So that's what I might have to do. I have to tear this apart, look at it, see what it is, and then mimic it. Because it is just a capacitor and some wire coiled around it somehow. I'm pretty sure. Well, that's what I think. Anyway, that's it for today. I've run out of time. I'm done. So tomorrow I will approach trying to recreate this capacitor. That's what will be on deck tomorrow. Thanks a lot for watching, and see you later.